For today's lecture, we will discuss about bearing stress and about thin-walled pressure vessels. Okay, so bearing stress differs from compressive stress in that the latter is the internal stress caused by a compressive force, whereas the bearing stress is caused by contact pressure between separate bodies. So bearing stress happens when there are two objects that are in contact. Okay, so for example, we have this rivet. Okay, now if you pull this two blocks, okay, these plates, two plates, no? Kung i-pull nimo ni siya, what happens is when the rivet surface contacts the face of the plate, there is a bearing stress that will be induced. Okay. Okay. So in order to calculate that bearing stress, again the formula is just force over area. Okay. Therefore, the bearing stress, okay, is just equal to PB over the area that is in contact. Okay? So, unsa na siyang area? This is just equal to this area, projected area, no? That is just equal to thickness times this one, D, or the diameter of the rivet. Okay, mo man yung rivet nimo. So, kung i-project nimo ni siya nga face, mo ni siya. D times T. Okay? Therefore, if you want to get the value of this force, PB is just equal to the diameter times thickness times the bearing stress. Okay, so you have examples here. Try to solve this one. Okay, naman ni siya solution, no? We'll proceed with analyzing thin-walled pressure vessels. So for this lecture, we will be analyzing the tangential stress and the longitudinal stress that is experienced by the cylinder due to the fluid pressure. Okay, so you have a thin-walled pressure vessel. So ang definition aning thin-walled is that ang iyang thickness over the diameter must be less than 1/10. You know, in order to be called a thin-walled pressure vessel. Kung greater ana, it is already considered as thick-walled. So lahi na po ang equation ana. Okay, so imagine that you have this cylinder, thin-walled cylinder, and it has a gas inside. So the pressure inside the cylinder will be distributed around the area. Okay, so nin ani. So in return, nani siya gi-exert ng force, no, perpendicular ani ng areas. Okay, so the question is, how do we analyze or how do we design the pressure vessel such that dili siya mo burst, no, dili siya mo fail. Okay, so let's cut a plane, mid plane, section A. Okay, so mo na siya. So what are the forces that are involved? Okay, so naa kay force, no? So kaning force, it could be anywhere. Okay, here along the ani. So for the general case, let's assume that it is at an angle theta. Okay, so you have the differential force. Now, pressure is just force over area. Therefore, in order to get this differential force, you just multiply the pressure times the area. So, asa ni siyang area? Kanina siyang area, diri, kani. Perpendicular sa imong force. So, kani siyang area is curve, no? Curve. Or, mura ni siya og arc segment, no? So, ang equation anang dA, or the differential area, is just theta r, or d, the angle, times the radius. So, d theta, and the radius is d over 2. So, mo ni siya nga times L. Kay, paano naman na dito? Mura na siya curve, then, multiply nimo sa ang length, no? Kay kanin siyang area, kani padung din eh. Therefore, the differential force is just P times L times d over 2 times d theta. Okay? Now, if we want to get the total force, okay? Total force, mura na siyang i-add tanan, no? I-add nimo ni tanan. But take note, okay, so kung kani nga force na adire, so ang iyang horizontal component kinaaman pud ni siya mag-exert man pud ni force dire. So ang horizontal component tanan mag-cancel out. So mahitabuan ni mo ni siya. Ang vertical force ra ang mag-contribute sa imong forces ani. So you have 0 to pi, i-add nimo tanan, no? Times PL d over 2 d theta times sin theta. Anong sin theta man? Kaya mo na ang vertical component naman ang mag-induce o stress. Kaya ang horizontal mag-cancel out man. So, this is just equal to PL d over 2 negative cosine theta from 0 to pi. Or kung imo ni substitute dire, you will get total force is just pressure times dl. Okay? Or mura siya og pressure times area, no? Projected area d times l. Okay? So mo din ni siya, no? D times l, P pressure times dl. Mo ni siya ang force nga mo try o burst sa imong cylinder. So, sa button cylinder ana is yan ang i-counteract with on opposite force P. Okay? So kung imo ni siyang isum ning forces ani, you'll find out that the force F is just equal to 2 times P. Okay? Mura na siya. And then, the stress in the longitudinal section, dari daw nga section, okay, kaning nga section, no? Kaning gamay ra. Kay thin ra man ni. Stress in the longitudinal section that resists the bursting force F is obtained by dividing it by area. Okay, so you have force. What is the force? PdL over 2TL. Right? 2T kay duha man ni ka area, duha man ni ka thickness times L. So cancel out ang L. We found out that the tangential stress, ang stress na ma-experience dire is just equal to PD over 2T. Okay, PD over 2T. So that is for the tangential stress. How about for the longitudinal stress, or ang stress nga ma-experience nimo dire sa imong end sa imong cylinder? Okay, so unsa man po na siya pag-derive? Again, you have this ang bursting force nimo is just pressure times area. So you have P, So unsa ang area? Kanina po na area. Kani. Ang area ni is pi d squared over 4. So mo ni siya. And then gi-resist na sa imo ang force P. Kani. Ang mo resist ana kay kani raman kani. Kani. Dinhi. Okay? So og yun sa pagkuha ang value aning P. Makuha na nimo siya by using the stress formula. Let's derive the longitudinal stress for a 10-volt pressure vessel. So ang longitudinal stress will be experienced kani nga area sa imo ang cylinder. Okay? Okay, kay yung nakay cylinder naman sa duha ka end, no? So unsa ang stress nga ma-experience niya longitudinal along diri nga length. So kanina siya nga area. Okay? So unsa na siya pag how do you derive that one? Okay, first is you determine the forces that will try to burst your cylinder. So it is caused by the pressure. Okay, so naam na pressure ng gases ni mo diha, no? Ana. Pressure P, small p. Okay, so ang small p, no, tanaw na to ang side view ana. Gaak na siya ana. Gaak. So ang bursting pressure force ana niya is just pressure times area. So unsa nga area? Kani nga area. Okay, so that is P times pi d squared over 4. Okay? And then, so what is the force pod na mo resist ana? So ang mo resist pod ana nga force is we shall call force P, capital P, no? Capital P. Una siya, ahaman na siya. Mo resist na niya diri sa imo ang kani nga surface, no? Kana nga surface. Kung isam na nimo tanan, mo ni ang capital P. Kung isam po nimo ni tanang forces diri, capital F. Therefore, summation of forces along horizontal is equal to 0. So you have capital P is just equal to F, or ang F na to is P pi d square over 4. But what is this capital P? Capital P nimo is just equal to P over area. Okay? So unsa ni nga area? P is sigma L times area. Sigma L is ang stress nga na-induce diri. So unsa na siya nga area? Kani nga area ani. Kani nga area, no? D man eh. D. Kani siya T. Thickness. So, gi-approximate ni siya ang area ani, no, okay, kung imo ni siyang i-cut diri sa may mahitabuan na. Dili siya straight. Sa may rectangle, no? Sa may rectangle, probably maana ni siya, no? Kung imo ning stretch o putlo nimo din, ana na siya. kani kay D plus 2T kani kay D na. So gikuan na lang nimo ni siya, giman na lang ning approximate diri na lang ka sa sir sa middle niya, no? So ang area ani would be pi d circumference, no? Kay kung imo ni putlon mahimo man na siyang circumference pi d plus t. Kay kuan man 1/2 t 1/2 t. Kung i-add nimo ni 1/2 t 1/2 t, so mahimo ning d plus t. Okay? Circumference pa ni circumference. Para mahimo ning area times nimo ni og t. Kay length pa man ang circumference is unsa ang length ani. Mao na siya. Therefore, mahimo na ning sigma L pi times d plus t times t. Okay? But if t is small, usually kay 10 man no compared to d, kung gamay di pwede daw nimo ni approximate to d na lang. Okay, so mahimo na ning p is just sigma L pi dt. Okay? So ato na siyang i-substitute dire, you have sigma L pi dt is p pi d squared over 4. So cancel lang isa ka d. Na, you have sigma L is p d over 4t. This is the longitudinal stress. Okay, so ang tangential stress PD over 2T. So mas gamay di ay ang longitudinal stress compare sa tangential. Ang tangential stress is kung morning nimo ang cylinder diri na. Pasabot ani ang strength sa imo ang longitudinal, ang strength dire katunga ra sa tangential. So mas una mo feel ang mo burst ang salubot sa imo ang cylinder, no? Ang kabantay mo mas una dyan sa mo burst. Okay? So mo una siya. Okay, for a sphere, no? Spherical vessel, thin-walled gapon, isa ra ni siya kay no kay pagkat nimo sa sphere, isa ra man na siya. So for a spherical vessel, ang stress experience niya is thin-walled spherical vessel. Okay? Sigma is PD over 40. So almost the same sa dire. No? For a spherical vessel. Mas ano ni? Gamay, weak. Okay? So, unsa man yung mga parameters kinahanglan ninyo? P is pressure, diameter. Tulo lang, no? Pressure, diameter, and thickness. Okay? That's it. Okay, so let's have an example in analyzing a thin-walled pressure vessel. So you have a large pipe called a penstock in hydraulic work. Now the diameter is 1.5 meters This pipe is composed of wooden stubs bound together by steel hoops, each 300 mm squared in cross-sectional area, and is used to conduct water from reservoir to a powerhouse. If the maximum tensile stress permitted in the hoops is 130 megapascal, what is maximum spacing between hoops under a head of water of 30 meters? Okay, the density of water is 1,000 kilogram per m cube. Okay, so what is asked is this one, L. Unsa daw ang spacing ani? Ang spacing sa imo ang hoops. Okay? So, in order to derive that one, we need to solve first or get first the free body diagram. Okay? So, kung mo na imong pipe, i-cut na to ni siya og half. This is the pressure niya is P pressure times dl, no? Based on our previous discussion. And then ang pressure nimo ay ang force nimo nga P na mag-resist ani para dili na siya mo-fail is just area times the sigma or the tangential stress. Okay? Okay, so summation of forces, you will get that PDL is just 2P, no? Based on this one. Okay. So we need to get the pressure. Ang pressure nimo is from fluid mechanics. No, wala pa may fluid mechanics, but using rho GH. No? Mo ni ang pressure head sa imong water, no, for 30 meters. No, kung nakay 30 meters na water, ang pressure sa bottom ana would be rho GH. Okay, so you have rho is 1,000 times 9.81 meters per second squared times 30 is equal to 294 kilopascal. So that is the pressure, no? And then multiply that by 1.5 ang diameter times L. Kani nga L. Okay? And then this is equal to 2 times P. What is P? Kani area times sigma. So ang unsa ang area ani? Ang area ani niya is thickness times L. Oh no. Ang area ani niya, given naman na yung area ani. No, na dari 300 mm squared. So 300 area 300 times 10 to the negative 6, no, to convert from millimeter square to meter square, times the sigma, stress 130 times 10 to the 6, given mo na dere megapascal. Okay, therefore we get that L is just equal to 0.177 meters or 177 millimeters. Okay, so that's it. So napay daghang example sa book, no? So try to solve as many examples as you can.